All right. So I apologize. I don't have these notes posted online yet, but I'll put that up after class in case you are collecting them. Just as a reminder, the project is due on Friday at noon. So we're now down to 48 hours for that. And then homework number 13, the last assignment of the semester, that's due the Wednesday after Thanksgiving. So we're going to continue talking about depreciation today. Remember the last time we discussed the straight line method and the declining balance method. And so today we'll discuss the modified accelerated cost recovery system. And then in addition to that, since it's relatively quick, we're going to go through a little bit of review related to just general time value of money type questions. Since the exam's cumulative, I thought it'd be a good chance to dust off some of those concepts because it's been a while. So, modified accelerated cost recovery system is just a simplified way of determining the depreciation amount that will occur each year. And it kind of takes away the necessity of having people calculate based on formulas and instead just relies on given factors. And the way it's set up is it's set up so that all equipment depreciates to zero. And remember that when we're talking about tax depreciation, it doesn't necessarily have to mirror the actual useful service life or the actual market value of the equipment. So in this case, the fact that it assumes that the equipment has no salvage value doesn't necessarily mean that all equipment will have no salvage value at the end of its life. This is just for accounting purposes. So the switch from declining balance to straight line depreciation is how they accomplish the zero salvage value. Because in the declining balance method, you can't actually achieve zero salvage. It just always goes to some given value for the salvage amount. And it starts off with a 200% declining balance, which means that the slope of the line during the first year is 200% of what it would be if it was straight line depreciation. And then it transitions about halfway through the recovery period to straight line to get it the rest of the way down to zero. And different types of equipment are assigned a standardized recovery period just as a virtue of the category that equipment is in. And we'll look it up off of a table to look at some of the categories and how long they assume that equipment lasts for tax purposes. And there's kind of a confusing, but I guess it makes sense if you consider it, a confusing convention that's applied in this cost recovery system. And that is if an item is assumed to have, for example, a useful life of 5 years, you actually take 6 years of depreciation. Because what they do is they only give you half of the amount during the first year to try and minimize the effect of people playing games with, for example, buying a piece of equipment on December 31st and then taking a full year's worth of depreciation in that first period. So to try and de-incentivize that kind of thing, they apply the half-year convention, which means that instead of a full portion of depreciation in the first year, you take a half portion of depreciation, and then all the rest of the depreciation is pushed downward through the period, but you'll actually have a half period of depreciation in the last year as well. So here are some of the different category types. And the class life, which is supposed to be more a reflection of how long they expect that it would actually last. And then there are different tax category recovery periods. And so if we just take as an example petroleum refining equipment, they anticipate that on average petroleum refining equipment will have a class life of 16 years. But then depending on which recovery period standard you're using, GDS or ADS, then it may have an accelerated depreciation period. So a company would prefer to use GDS in the case of having to spread that cost out over a fewer number of years, meaning that they get to accelerate the depreciation sooner rather than putting it off towards the end where the depreciation doesn't have as much value. You can see some pieces of equipment have a really long assumed life in the case of like gas utility distribution facilities, and so a lot of pipelines have been put in West Virginia recently, and in many ways they're permanent investments. I mean, eventually over the really long term those pipelines will degrade, but they're built to last because of the effort and disruption that it takes to put them in the first place. They're not wanting to take out the gas distribution facilities and replace them very often. So they don't literally last forever, and so they are depreciable, but they still have a really long class life, and so the depreciation speed is pretty slow for some types of equipment. Then for others, things like automobiles, the depreciation is relatively fast. So once you know the category, then you would find out how long it should be depreciated over. So in the case of automobiles, using a 3-year recovery period, then what you'll notice is it's 3 years of recovery, but there's 4 years that the depreciation occurs during. So the first year is a half portion of depreciation as compared to how much it would be if it was a full year. Then there are 2 subsequent years, and then the last year is a half portion of depreciation as well. So you can kind of see the trend a little bit more obviously in some of the longer recovery periods, because what you can see is that the depreciation factor is nonlinear for a few years. So you'll notice that it's decreasing. The depreciation factor here in the 20 year starts off at 0.07 and 0.06, 0.061, 0.05. So it's declining, but then it becomes fixed. And so this is when it becomes 0.0447 is where it's transitioned into the straight line depreciation. And it occurs as a straight line depreciation amount until the final year where you're getting that half portion of depreciation. So it's 20 years spread out over 21 periods because of the half-life convention. Okay, so let's get some practice using these ideas. Let me show you the in-class exercise that I've got for today. So we're going to be looking at a copy machine system, and we want to find out for a copy machine system, first of all, what is the recovery period that will apply, and then how much depreciation is there in each year, and what is the book value at the end of each year. So you'll notice that the table of depreciation factors starts with year 1. And so what that means is that obviously the book value at time 0 is the initial purchase price, but then at the end of the first year, the book value should be lower. So what you need to do here in applying this is, for each year, calculate, given the factor, it's just a decimal, so the depreciation amount is the book value multiplied by the factor. So you find the depreciation amount and the book value at the end of each annual period. Okay, so it's a 7-year recovery period, which means because of the half-year convention, we'll actually have 8 annual periods that we take the depreciation over. And so you can see that I started just by transcribing the recovery period table. So all of these factors as they're presented in the table. One little thing that's kind of weird about it is, I guess, they want it to add up to exactly 1. And so because of that, it goes from 0.0893, 0.0892, and then back up to 0.0893. I mean, in the end, it all adds up to 1.0, which is what it's supposed to. But I think it's a little bit weird that it seems like maybe they would have had the 0.0892 as the last one, but that's not. It's in the middle. In the end, it has a pretty minor effect on how much depreciation occurs in any given year. You can see that the depreciation amount in the first year in terms of dollars is just the book value multiplied by the depreciation factor. And so then the book value at the end of that year is going to be the initial cost basis minus the depreciation amount for that year. So at the end of the first year, the book value is $29,741. And then in each subsequent year, the book value is just the previous year's book value minus the depreciation amount for that year. So the indicators that we've set everything up correctly is, number one, that the sum of the depreciation factors is equal to 1. And then the other indicator you should be looking for is in the MACRS, remember the book value always goes to 0. So if your book value doesn't terminate at exactly $0, then you've got an issue as well. So any questions about that approach for calculating depreciation? Okay, now on the back side of the paper are a couple of time value of money questions. And these are things that we haven't looked at directly in a little while. So we've got 3 questions, and then on the second page of the handout is the factor tables and formulas. So 3 questions, just I'll leave it. I won't try to interrupt and explain things prematurely because I want you to reason through this and kind of remind yourself how to do these calculations, and also importantly how to annotate, or like the standardized notation method that we use for summarizing problems. So remember, there was like find P given F, find A given P, that kind of annotation style that we did inside of the parentheses. I think it's a good idea to refamiliarize yourself with that approach. So if you don't have a factor table for the percentage that I mentioned, then that means you should use the equation method. Okay, I've got the solution to the first one up on the screen. So if you're going to get $85,000 in 7 years, then that's defining a future amount. So that's F. And if you want to know the purchasing power of it, then we're looking at the inflation as the interest rate. So this one's just find P given F. So it should be $61,424 is the current value of that future amount. Okay. So any questions about that first one? Okay. In the second question, it is a nominal interest rate of 12% compounded monthly. So nominal means that the effect of compounding isn't taken into account in expressing the interest rate. So the way that you'd find the interest rate per period in this case is you just divide the nominal interest rate by the number of compounding periods in a year. So there's 12 compounding periods in a year since there's 12 months, and that makes I, the interest rate per period, just equal to 1%. And in this one, we do have a 1% factor table. If we look at the provided equations and factor tables, here's the 1% factor table. And it's talking about making a purchase now and trying to find out, based on the payments, what's the present value of it. So we're given A, and we're trying to find P. So that's find P given A. That would be this column. So we want to know what is the factor for find P given A with 30 periods. And you can see that the factor there should be 25.8077. Okay. So 25.8077 and then multiplied by the annual payment amount. Well, it's not annual, it's each month. But we just refer to the variable A as meaning it's a uniform series amount. So the present equivalent of those 30 payments is $5,792.54. So any questions about that? That would actually be a pretty good interest rate for store credit. Usually store credit is about the same interest rates as credit cards, which is 24% per year and higher. So I'm not saying this furniture is a good deal, but I'm saying their credit's a little bit lower than you might expect if you actually went into a store and tried to make a purchase. Okay, the last question is maybe the trickiest because it's invoking this phrase capital recovery, which has two parts. And then beyond the two parts, you have to look at whether it's asking what is the capital recovery or whether it's asking what is the amount of new revenue that should be earned in order to cover the capital recovery, because those are equal but opposite quantities. So capital recovery, remember, as I've illustrated on the board here, you're given a purchase price, which is an outflow, and you're given a salvage value or a sales price in some future time, and that's an inflow. So the inflow that you get in the future is going to be less valuable than the purchase price today. So the net effect of that, if you're going to annualize it, if you annualize both, is that it's going to be an outflow each year. So it's the cost of ownership on an annual basis when you take into account the purchase price minus the salvage value. So then here it's being asked, once you know the ownership cost per period, how much new revenue do you have to make? And so that'll be a positive amount, whereas because it's an outflow, the ownership cost is a negative amount. So here in the calculations, we have a find A given P. The interest rate is 6%, N equals 7. So we can determine the factor for that, and then multiplying it by the present cost, find that the annualized cost of the initial purchase is $11,643.78. You can see here in the side of it, I've indicated that's a cost, that's an outflow. But then the sales price of $18,500, 7 years in the future, that's an inflow, so we're going to subtract the two. So $9,439.78 is the annual cost of ownership, and so then that is how much new revenue that you should make each month to justify that vehicle purchase. If you can't make at least that much additional revenue, then the purchase that motivated it is not justified. So you will have a couple of just basic time value of money questions like this on the final exam. And our midterm exams have only been 50 minutes in duration, but the final exam's 120. So my thinking was I plan to make the final exam about twice as long as the midterm exams have been. Even though you have more than twice as much time, I'm just, in my mind, trying to plan to write it to be take twice as much time. So maybe people who work quickly typically seem to be finishing in about half the available time. So, some people will probably finish the exam in less than an hour, and some people may take the full 2 hours. But you will have some of these simple time value of money questions from way back in the early part of the semester. And you need to be able to use either the factor tables or the equation method. And just one thing I'll mention on the second problem where we use the factor table, we were able to report the answer to the nearest penny, and that is accurate in this case because this particular factor table reports the P/A to 1, 2, 3, 4, 5, 6 digits of precision. So that means we can retain 6 digits in the final answer, which in this case gets us to the nearest penny. So it depends on the factor table that you're using. Some factor tables may only have 4 digits of precision for certain of the factors, and in this case it was 6. So be sure to remember that you need to round off accordingly as a reflection of whatever factor table you were using. Okay, so when we get together on Friday, we're going to introduce some ideas related to uncertainty and how to do financial planning and accounting when we don't exactly know what our rates of return might be in the future. But before then, I think the real point of focus should be finishing up the project. It's due on Friday. You now have 47 hours to finish that. So I will see you in class on Friday.